In 217, a paper called Attention is All You Need changed everything. In 219, OpenAI scaled it into GPT-2. In 220, GPT-3 blew people's minds and still couldn't answer a simple question reliably. Almost simultaneously, DeepMind was perfecting a completely different field of AI, reinforcement learning, that had just beaten the world's best Go player. What happened next is the story of how two separate research traditions collided and created the most influential technology of our generation. This is that story. OpenAI's bet was on scale. The transformer architecture introduced by a team at Google in 217 showed that with enough data and compute, a model could learn to predict text with remarkable sophistication. GPT-1, GPT-2, GPT-3, each generation just more parameters, more data, more compute. GPT-3 had 175 billion parameters trained on hundreds of billions of words from the internet. And the results were astonishing and deeply frustrating. GPT-3 could write poetry, code, essays, but it was fundamentally doing one thing, predicting the next token. Given text, what comes next? It was the world's most sophisticated autocomplete. It completed your sentence, it didn't really help you. GPT-3 auto-regressive training procedure tasked the model to predict a token based on previous text. It was optimized for text completion, not dialogue. It had no concept of what you wanted, only what statistically come next. This is the core problem. Raw language model pre-training produces a system that knows almost everything and has no idea what to do with the knowledge. On the other side of the research world, DeepMind was working on something completely different. They weren't trying to predict text, they were trying to teach machines to make decisions. Reinforcement learning is one of the oldest ideas in AI. An agent takes actions in the environment, receives rewards or penalties, and learns to maximize reward over time. Simple in theory, but brutally hard in practice. DeepMind's breakthrough with AlphaGo in 216 proved that RL at scale could produce superhuman decision making. The key insight from that work, you could use neural networks to represent the policy, the function that makes states to action. They were first who combined deep learning and RL, and they received a system that could learn complex strategy from experience. But the problem with RL is that you need a reward signal. How do you reward a language model? Good answer isn't a number. You can't write an equation for helpfulness. This is the bridge that needed to be built. In 222, OpenAI published a paper that built that bridge. It was called Training Language Models to Follow Instructions with Human Feedback, and it introduced RLHF, reinforcement learning from human feedback. The paper introduced an approach to bridge the gap between raw language model capability and human intent by fine tuning LLMs using reinforcement learning with human feedback as the reward signal. The method had three stages. Step 1 was supervised fine tuning. Take ChatGPT 3, have human labelers write examples of what a good response looks like, fine tune the model on these examples, and now it has a better starting point. Step 2 is reward model. Show human raters pairs of model outputs. Ask them which one is better. Collect thousands of these comparisons. Train a separate neural network, the reward model, to predict human preference scores. Now you have a proxy for what humans want, expressed as a number. Step 3 is reinforcement learning fine tuning. Use the reward model as a reward signal. Apply PPO, proximal policy optimization, and RL algorithm to update the language model toward outputs the reward model scores highly. The language model now has a training objective aligned with human preference, not just token prediction. And look at the results. A 1.3 billion parameter Instruct GPT model outperformed the 175 billion parameter GPT-3 on human preference tasks. A model 100 times smaller because it was actually optimized to be helpful. ChatGPT, launched in November 2022, was built directly on this methodology. It reached 100 million users in 2 months, the fastest growing application in history. This is how two different technologies combined could give us a really helpful, sophisticated tool. Reinforcement learning human feedback worked, but it had a critical weakness: humans. Human labelers are slow, expensive, inconsistent, they disagree with each other, they get tired, and crucially, as models approach or exceed human level capability in certain domains, human raters can no longer reliably judge which output is better. So Anthropic asked, what if the feedback came from another AI? This is RLAF, reinforcement learning from AI feedback. Instead of human raters ranking outputs, you prompt a language model to score response based on a set of principles. The feedback signal is generated automatically at scale and consistently. Anthropic's constitutional AI was developed to address two problems with earlier RLHF training: the high cost of hiring people to label harmful content and the tendency of resulting models to simply refuse sensitive questions instead of responding in a helpful, nuanced way. This method works in two stages. First, a supervised learning phase. The model generates answers, then checks each answer against a list of principles in the Constitution, critiquing and refining its own outputs. The model is then fine tuned on this self revised dataset. Second, an RLAF phase. A language model is used to compare response pairs according to constitutional principles, generating preference labels. RL then proceeds as normal, but using AI-generated preferences instead of humans ones. Anthropic published constitution drawn from the UN Declaration of Human Rights, Apple's Terms of Service, DeepMind's pair of principles, and non-Western ethical perspectives. 58 principles in total. Anthropic found this produced what they called a Pareto improvement. The model became both more helpful and more harmless, with zero human labels on harmlessness. All the safety gains came from AI supervision alone. This is Claude, and it's a fundamentally different approach to alignment. So, what actually happened? OpenAI scales language models until they know everything but can do nothing useful. DeepMind proves RL can produce superhuman decision making. RLHF uses both, using human judgment as a reward signal. RLAIF and constitutional AI take that further, replacing the human bottleneck with principied AI supervision. Each step was necessary. Each was built on the one before, and the technology that results, the ChatGPT, the Claude, the Geminis, wouldn't exist without the full chain. And we're not done yet. The next frontier is whether AI can generate feedback that's not just consistent with human values, but better, catching things humans miss, applying principles humans can't articulate. That research is happening right now. I left some useful links in the description, and if you like this kind of tech content, please subscribe to this channel.